In question number 16, a spherical cavity of radius r by 2 is made in a spherical object of mass m and radius r. A particle of mass small m is placed at a distance 2r from the center C of the sphere as shown. The gravitational force on the particle is. First, we need to find what exactly will be the gravitational field here, and just simply we shall multiply the gravitational field into small mass m. It's been said that total mass of the spherical body to be equal to m and the spherical cavity of radius r by 2. That means r by 2 cube will be how much? It will be r cube divided by 8. So the total mass, if it was m, this portion, the cavity which actually has been taken out from here, must have a mass of m divided by 8. Fine. So now I will calculate the field at this point because of the system. Field G capital M, this distance from here to here is actually at a distance 2r, so it will be 4r square, fine, minus G, mass of this cavity is m by 8, and the distance from here to here, it is 2r minus r by 2, it is 3r by 2. So it will be 9r square into 4. This is the effective field at this point. So have this calculation. It is capital G m divided by r square. This will cancel out. So we are left with 1 by 4 here and 1 by 18 here. So this value is coming out to be 7 gm divided by 36r square. So now the force on this particle will be how much? It will be 7 gm small m divided by 36r square. So for question number 16, we are getting option 2 as the correct answer. Now we shall proceed to question number 17. In question number 17, an ideal monatomic gas undergoes through a process in which its pressure P and volume V are related as V P to the power 1 by 3 is equal to constant. The bulk modulus for the gas in this process is. What we know, the bulk modulus actually has been defined as dP divided by dV by V must be equal to minus of P. Fine. So we will try to evaluate this particular function from this equation. Well, let it write down as V P to the power 1 by 3 is equal to constant. So its differential V 1 by 3 P to the power minus 2 by 3 dP plus P 1 by 3 dV must be equal to 0, or from here V divided by 3 dP plus P dV, it must be equal to 0, or minus V dP equal to 3 P dV, or minus dP divided by dV by V is equal to 3P. So we are getting option 1 as the correct answer for question number 17. This is the value of the bulk modulus. Fine. Okay, now let's proceed to question number 18. In question number 18, the weight of a body at height h is same as at the depth h from the surface of the earth. If radius of earth is r, then value of h is. Here we will be calculating the value of the gravitational field at depth h and at height h. So it will be G capital M r plus h whole square at height h will be equal to G capital M r minus h divided by r cube. These two portions will cancel out, and we'll be getting this value r cube would be equal to r square plus h square plus 2rh into r minus h, or proceeding with it r cube minus r square h plus rh square minus h cube plus 2r square h minus 2r h square. This one will cancel out. So solving this part, we'll be getting the value of h to be equal to root 5 minus 1 divided by 2 into Fine. So looking into the option, we are getting option 2 as the correct answer for question number 18. Now we shall proceed to question number 19. In question number 19, a car is moving towards point C with a speed 72 km per hour and blows horn of frequency 640 Hz when it is at point A here. A person is standing at point B as shown in figure. The frequency heard by the person is, speed of sound is 330 meter per second. We need to find the frequency heard by this person. Well, this distance that actually being mentioned here, it is 1000 meter and this one being 1732. So effectively I would say this angle to be how much? 60 degree. Got it? It is actually ratio of root 3 divided by 1. Now the frequency here, it is 640 Hz and the speed of this person along this direction, it is 72 km per hour. Converting it in meter per second, we are getting this velocity of to be equal to 20 meter per second. So velocity along this direction will be how much? It will be along this direction, it is 10 meter per second. Now frequency heard by this person B, it is F. F will be equal to V, here it is V minus 10 into F naught, that is 640. V was how much? 330 divided by, so this one will cancel out, or we are getting this F equal to 660 Hertz. So for question number 19, we are getting option 3 as the correct answer. Now we shall proceed to next question, that is question number 20. Here in question number 20, the average speed of molecules of oxygen gas at 27 degrees Celsius is approximately. Just see the options and find out which one is correct one. Well, we should be starting with first taking the temperature in Kelvin scale. It must be T is equal to 300 Kelvin. And from kinetic theory of gases, what we know is that V average, it is to be written down as square root of 8 RT divided by pi m naught. M naught is the molar mass of oxygen molecule here, that is to be taken as 32 gram per mole. So putting the value here, V average, its calculation, it comes out to be 8 are to be taken as 8.314. This is 300 Kelvin. This is pi and it is 32 into 10 to the power minus 3 kg per mole. Fine. So this is the value here. So if we make the calculation, this value comes out to be very close to 445 meter per second. So for question number 20, option 2 is the correct answer. Now let's proceed to next question.